When we add or subtract radical expressions, we have two conditions that we need to check before we can begin the addition and subtraction. The first condition that we check is that the radicals have the same index. We need them to be the same root. The second condition that we check is that we need them to have the same radicand. That is the only way that we are actually able to add them together, because what we're adding is actually the numbers that are going to be outside of the radical, not inside of the radical. We're treating these like terms, where we have an amount of something that we are combining together. Now, for this first example, you'll see that we have the same index. These are both square roots, but we do not have the same radicand. We will engage in some process to ideally get those two radicands to match. So we look for a perfect square that goes into 12, and we factor 12 as 4 and 3. So we can say 7 times 2 root 3, taking the square root of the 4. And then over here, we're going to look for the biggest perfect square, which is 25. That's going to turn into the square root of 25, which is 5, leaving us with a root 3. Now our radicands match. So once we were able to do that factorization with the 12, we have our two radicands that match. This is 14 root 3. This is 5 root 3 for a grand total of 19 root 3. Notice that the inside does not change. That is reserved for multiplication and division. The addition and subtraction of radical expressions does not change the radicand. It only changes this number on the outside, as that is the number that we are actually combining. Trying another one, slightly more complicated because it has x's in it, but that's not really going to change our work too much because the x is in both of the radicands already. So let's look again at those numbers that are on the inside. We have a 12 here, which we saw in the last example, factored to a 4 and a 3. There's our perfect square and our leftover. Same thing here, we're going to go 9 and 3. So here we'll have a 3 times 2 root 3x. And over here, we'll have a 6 times 3 root 3x. We didn't touch the x. That 3 still left over. That 9 turned into a 3. We didn't touch the x. That 3 is still left over. That 4 turned into a 2, as we took its square root. 3 times 2 is 6. So this is 6 root 3x. 6 times 3 is 18. So that's 18 root 3x. Subtracting the two of these, we get negative 12 root 3x. We need the index to match, and we need the radicand to match. The index matching is easy. We're going to see that right from the jump. We're going to know right away if our indices are going to match. The radicand is where we're going to have to do most of our work.